Yes, sir.
I'll put it in the.
And the recorder is on.
Okay. We'll start in 5 minutes because we have 30 minutes of slot and. Hello everyone. My name is Yogen. I'm from Arna Networks, and today I wanted to bring up this simplified network slicing solution which we have built in the 5G Super Blueprint to enable the community to consistently have the slicing solution to be reused it for various use cases. So previous sessions which we went over, the one before this one, and we have seen 5G Super Blueprint is all primarily based on the use cases, and one of the important use cases which we have exercised in the past was network slicing, and we have used ONAP as one of the means there, and we have integrated with a couple of specific vendors to do that. But however, to repeat that again and again, we needed a simplified view so that you can take any point of time and take the next advanced use case out of it. So the idea of this demo is to demonstrate how one can use this as a base and build the advanced use cases on top of the network slicing. So I'll just outline the agenda today. So we will quickly touch base on what was the goal and the activities we have tried, and what are the various software components we used to build this thing, and what are the challenges we encountered it, and how we try to solve some of them, and and some of the outcomes of it we are going to upstream it to the open source community, and how does the overall test setup looks like in the demo, and followed by the next steps, what we wanted to incorporate in this slicing solution so that community can take a repetitive advantage of the same solution. So quickly touching on the goals and activities. So the thought process was to build a very lightweight slicing management network function. We have also something from ONAP similar, but ONAP has a big component SO which does everything in one element. And what we learned from the community and from the various customers and the use cases is that slicing network function management, it can be actually an independent microservices, and they should be easy to manage and independently can be taken over. So that was the thought process. So what we did is we came up with CSMF and SMF as a separate slicing solution, a microservice, and then we have built separately the RAN NSSMF, core NSSMF, and transport NSSMF, which will integrate with the southbound with any kind of stack, whether it's open source or it can be proprietary. So based on use case of the 5G Super Blueprint and the various vendors which participates, they can make use of this integration and can showcase the advanced use cases. One of the thought was to make this as a cloud native thing, and that's why we built it as all microservices, and each of them talks to each other and can be managed separately, and its own lifecycle is there. One of the things is we also built a very lightweight version of a BSS reference implementation, which is inspired from the TMF forum, and we have implemented slice ordering from there, and which talks to the above CSMF and SMF components to create the slice and do the lifecycle management of it. So in this demo, what we have picked up is two open source stacks. One is from the RAN side, one is from the core. From the core, what we have done is we have picked up something called Free5GC, and for the RAN, what we have done is we have picked up the UV-RAN SIM open source project. And one of the main objectives what we have set for is to take a leap on this implementation, is to have the slicing solution matching to 3GPP latest release of 18.x series. So the previous versions of open source, what we have is is in like release 16 or something we are trying to do. This has taken a leap altogether, and it supports the 18.1, 18.2 of the slicing and the 5G NRM specs. And all this solution is built over the central orchestrator, which is MCO. And so basically MCO is in the middle, and think about these other components are just around it. So that was the overall thought process, and MCO has been used in our 5G Super Blueprint, and we wanted to make this slicing solution more consistent and automatable, so that we can build the final various use cases there. I'll just touch base on the software component. So like I was mentioning, the slicing management network functions, what we have built up is our microservices, and those are the 5 microservices. One is called a slicing processor, which contains CSMF and NSMF functionality together. And then you have 3 RAN and SSMF, which is responsible for managing the RAN domain. And then you have core network and SSMF, which is responsible for the core network, and transport and SSMF, which is primarily responsible to stitch the RAN and the code. And all of this is totally is coupled around the MCO. So what we have done is we have picked the MCO version 2209 for this demo, and that's what is got integrated. And from the open source RAN and the core side, we have picked the URAN SIM and Free5GC versions are the latest versions of this software. And here are some of the license types, which is to showcase that the changes what we have made done, right? So they have to be upstream for specific reasons. If it is GPL, it has to go upstream, right? So we have made some changes on that. And then similarly on the Free5GC, which is Apache, there also we have made changes, and we wanted to give it to the community back so that community can take the advantage, and people can do more advanced use cases on it. So one of the things which I want to highlight here is the day-end configuration changes if you have to do in the Free5GC and URAN SIM was not there. So that is something which we have added as a new support into this stack. And this is what we're going to upstream it. So here's a high-level architecture and the flow for the demo today. So what we're going to show is this green ones are the newly built up elements, and each of them has the slicing network management function plus the interface to talk to the MCO. So what we are thinking in the future is, if it is an FU or any other use cases, so this same software can just integrate with another interface of the orchestrator, and then the slicing solution can just continue to demonstrate the same thing again and again. So the demo what I'm going to show today, it contains of these microservices, and you will have a G node be running in one of the edge cluster, and then you have Free5GC running on another cluster, and the whole this management functions itself is going to run on a management cluster. All of them are Kubernetes clusters there, and what we are showing is the UE is going to first, after the orchestration of the slices happen, UE is going to connect to the core and RAN, and then subsequently the UE is roaming around in the network, so he will get this deregister from the core network and will re-register it, and we are simulating a mobility use case using the slicing. Okay, so some of the challenges which we encountered is one of the thing is that the Free5GC and URAN SIM, they don't have the support of configuration changes. So if you want to do a configuration change, you have to restart the whole thing. Right? So this is a one big limitation. If you have to do slicing, you don't want to restart everything. So that's one of the support which we added now in the Free5GC and URAN SIM. And now Free5GC, if they have a lot of network functions, right? And each of them has its own interface to take the configuration changes. So for slicing perspective, whatever the attributes were required, we have enabled it in the stack, and we're going to upstream it to the community. And similarly for URAN SIM, they don't have an interface to consume the various slicing parameters like PLM, MNC, SST, SD values. So what we have done is we have added the support of REST interface in the URAN SIM, and that's what we're going to upstream it because it's a GPL, right? And then anybody can start making use of it to do a better next level of advanced use cases. Then the kind of issues which we encountered was the ordering of the URAN SIM and Free5GC. So in the slicing situation or any normal network deployment, what will happen is you will bring the core network or then the RAN independently, right? And in order to it should work independently in any order you bring it up. But with the Free5GC and URAN SIM, if your URAN SIM comes up first and then Free5GC comes up later, which is what the common case was we are encountering. So seems like the URAN SIM doesn't connect to the Free5GC. So what we have done is we have enhanced the URAN SIM source code to retry irrespective of any ordering when the Free5GC comes first or the URAN SIM comes first. So it has to pass through the SCTP connection and succeed in connection with the AMF. So that changes also we made it. So all of that is going to be upstream to the community. Next is what we did is we separated out the UE and GNB so to demonstrate this mobility use case. So when you bring up the network, so you will have Gnode B up and running and core network up and running, and then we'll install the UE separately, and then demonstrate network coming up with the UE, and then the UE will move out from the cluster and will deregister and again re-register back. So that way you can emulate mobility use case. So in this solution, one of the things which we are trying to do more better is edge selection, and that's where in the morning session we saw from Rodney, right, about edge placement and the site selection, right? So this is what we needed to incorporate in this solution to next stage. So meaning when you create a slice, we wanted to select the edge which has more better latency in terms of and bringing up the UPF to be installed on that specific site, right? So that's the thing which we wanted to take it to the next stage, and that's something which we haven't completed yet. So we wanted to go to the next stage on that. Here's the test setup and the demo which I'm going to show now. So so this is what in the center you have the MCO, and then you have this network management function for the slicing, which is responsible to take care of the slicing lifecycle. And then if you see that the step number one is the actor is the operator is going to order something for the BSS slice, and then it will go to the CSMF and SMF, and it's CSMF and SMF is going to talk to the MCO, and MCO is going to onboard these two target clusters, which is your one for the core, one for the RAN, right? And after that, what is going to happen is 1 and 2 steps when it finishes. So clusters is onboarded. When the slice order is ordered, so basically the core NSSMF and RAN and SSMF are responsible to talk to the MCO and then instantiate this network functions, which is for core is responsible for free 5GC, and RAN and SSMF is responsible for URAN SIM to bring it up. Right? So this is what is going to happen. So the central of this demo is MCO is the one which is the open source component which we are using it, and these are the natively built new ones. Okay, and then after the orchestration is done, core NSSMF and RAN NSSMF independently are going to do the DN configuration changes to the network functions. This is what is the new addition which has been done to the stack of the free 5GC and the URAN SIM. Okay, any questions at this point? Otherwise, I'll go to the demo.
Again, quick question. Above the sequence diagram you've shown, the CN NSSMF and RAN NSSMF is part of MCO, but this diagram you think is treating it as a separate component, is it?
Yeah, so here when I'm showing it, the idea is this CSMF and SNMF is talking to MCO client. So basically, a client API portion I have implemented in that.
I see. Okay, that's the expression. Okay.
So basically, I'm looking in the next version. If the nephew comes up and nephew exposes the API, so basically this network function has to just implement a client version of it in its code, and then it is done.
So what are you using to execute NSMF or CSMF?
So what we're doing is it's driven by the ordering service order which you put it, right? So the service order is the one which will tell what is the characteristic of slice one operator is looking at it, right? And based on those attributes, we break down into the communication service parameters and then translate into the network related parameters, and then it breaks down to the slice profiles of it.
So the function runs inside MCO?
No. So these are independent. It talks to MCO through the MCO client interface, which we have built it inside each of them.
This diagram confused me. That's why I asked you. Okay, yeah, it looks like part of the MCO.
Just think of the MCO is running separately, right? But then you have MCO to exercise. You need to call their APIs, right? So those APIs are one I'm representing inside each of them in the previous drawing. Yeah.
One more question is the diagram. This CSMF and NSMF and CN, is that part of ONEP or is going to be external NSSMF?
These are the ones which we have built natively as separate ones. And then, so this is the lightweight version. So you don't need a full SO and the ONAP for doing this. So just to take this Helm functionalities, I mean the cloud native network functions which we have built, install it, and then you're ready to demonstrate the slicing endpoint.
Okay, thank you. Because ONF has that too. So you separate for simplify the POC.
Yeah,
Okay.
yes. That the idea is because what we realize from multiple customers is, they don't want to use the whole own app. I mean, they wanted something independently because they wanted to end up doing integration at this point. So at a RAN or a core, right? So they have to take the whole big bunch of things. So we said, why don't we just simplify it and make it out a separate element each of them? So the lifecycle management is also easier then.
Thank you.
Okay, so I have pre-recorded demo. So it has also an audio, but I have muted that audio. I'll just talk through it. Just a quick time check. We have 15 minutes. Okay. So in this demo, what you'll see here at the bottom, you have a BSS, a client. This is client from I'm actually triggering the API calls. And ASP is the one which contains CSMF and NSMF functionality, which if you see in the drawing, I had this one, right? So I call that as a slice processor. And then you have core NSSMF and RAN NSSMF and transport NSSMF. So we have all of this built up, right? The transport NSSMF is the portion which is is a dummy at this stage. It is not a full blown solution, but RAN and the core and the ASP is a fully blown thing. It's up and running. And BSS is a reference implementation which is talking to the ASP and ordering the slice things. Okay. So I'm going to just run it quickly and show that on a management cluster, you have AMCOP running in. AMCOP instance here is basically a representation of the MCO. And these are the bunch of microservices which we have built and we are installing it independently. So they are running in the default namespace in this case. Okay. I'll just speed up this. So it has two portions. First portion of the demo will showcase that we are onboarding the two target clusters using the ASP. And then second portion of the demo will actually do the slice ordering and then instantiating the all the network function. And then we are going to run the UE connecting to the network and deregistering the net from the network and re-registering for the mobility use case. Okay. So that's good. So if you see here on the top, you have the RAN management cluster is separate and there only the Kubernetes cluster is running and nothing else is installed. Similarly, on the core cluster is a separate one. And you'll see only the Kubernetes cluster is running and nothing has been installed. And these two clusters, we're going to install the slicing base orchestration. So which means it is nothing at this point of time. When we order a slice, automatically this network function will come up in that. Okay. And we'll also look at what does the payload will look like. I mean, how does the user is specifying the characteristics of the slice, right? So, so here, so what we are doing is to onboard the target clusters, right? We have the kubeconfig file of the RAN and the core, and that's what we are going to supply it to the ASP to perform that activity. Okay. So I have locally present that file, and I'm going to show that. So I have a program written in Python, which will actually, has made easy things to, user to supply and say that, I want to create a slice or delete a slice, or, what is the status of slice, activate, deactivate, or create or update a slice, or create a network, delete a network, or, get the status of it network. So here, create network and delete network is essentially a representation of onboarding the target cluster in an MCO terminology, right? And there is an input parameter which will tell that what is the parameter which is required for the respective action. So, so for example, if you have we create a network, so ASP will give you back a handle, meaning an ID through which you can query and check the status of MCO has reached what stage of instantiation of it. So here is the payload where we are saying there is a tenant and the tenant is a customer A, and that you can specify that who is the provider for that cluster. So we give you a picture named like Xtel, and what are the clusters you want to onboard it. So we have given one name as core cluster, and the other one would be the RAN cluster and their respective kubeconfig file where it is present. Okay, and this kubeconfig file will be will be going into the ASP, and from there you will be able to trigger the integration with the MCO to onboard the cluster. So I'm just showing you the first action where we are creating the network, and we supply this payload. So I have that payload locally present there, and I call it as a lock network payload. And So when you issue it, you get an ID back. This is ID through which you can actually query and check in real time that MCO has instantiated this network onboarding or not. Right, so you can check here. So you can supply this parameter and give an ID and supply this parameter, and you'll know that alloc network is in progress. And if you just wait for a couple of more minutes, then it will finish the process. Right? And you can actually go back and look at the ASP logs to see what has happened. So if you see here, you receive an event in the ASP to perform allocate the network, and this is the payload which we were showing it up earlier. Right? And similarly, this is the BSS. On the BSS, we did an event. So when you ordered from the client, right, the BSS has received that event, and BSS has then ordered the ASP to perform the onboarding of the cluster. So here you can see now in the ASP logs, a customer A has been onboarded, right, and the respective clusters are getting up. So here is what I was saying, MCO client. Basically, we are calling all the APIs of MCO to to do that. So now, if you just again check the ID, you will see the status is completed there. And you can see now in the logs that cluster created successfully. And if I run it back, you will see allocate network is completed. So meaning the target clusters are onboarded in the ASP. So your from end provider, if you see, they know what is the underneath infrastructure they have it, right? And now they wanted to proceed with slice creation on top of it. So now we'll see what is the slice parameters it is going to take it, and then going to instantiate the RAN and the core. So I'll just bypass this. You can verify that on the MCO GUI also. So this is what I'm trying to show there. I'll bypass it because of to save some time there. Yeah, so we'll come to the slice creation portion of it. So here is a payload. So what I want to show in this payload is there is a service notation, and you can give a name to service, an identifier, and a description. And then you can actually tell who is the service provider. So you can say, think about one company who wants to offer multiple slicing solution to another customers, right? So that's the order in which you can create the things, and you can specify which tenant namespace you wanted to use for that. So you can specify that parameter also, and what type of service. So we are saying EMBP service we want to create it in this case. And then what are the parameters for this slicing would look like. So we are saying it here. If you see the bottom section, there is a request input. So these are the parameters for the slicing, and what are the resources are relevant for the slicing. So we're saying there are two resources, one for the core domain, one for the RAN domain. Okay. And then we tell that, for the core domain, when you instantiate the slice identifier is, SNSSCI. And we are also telling that, what type of service you want to create, one for the control plane, one for the user plane. And for signaling, free 5GC will come up as a separate. And for the user plane, the UPF will be the another service. So two services will get created in the core domain. And in the RAN domain, we're going to bring up only one integrated G node P. And only the G node B would be there in that. Okay. And these are the parameters for the slice characteristics. So through this, actually your operator is telling that I wanted to create a slice which should have this as a characteristics. And this is what needs to be ordered by the underneath infrastructure and the stack, which is the free 5GC and the URANs in this case. So a lot of these parameters are not supported today by the free 5GC and URANs. So we have at least max number of UEs is one of the parameters. We have added the support in the URAN SIM code. So now if you use specifies here the limit, based on that, actually, when you bring up the slice, the network function is provisioned with that it's allowed to do only this many UEs to attach to the network. Okay, so I'll just fast forward that a bit. Okay, and we will create the slice here. So here I'm issuing the same payload which we showed, and we enter it. So I just want to enter a couple of spaces there so that we can see the logs. So the core NSSMF is running already, and RAN NSSMF is running, and the transport NSSMF is running already. Okay, so we'll issue this slice creation now. These are previous logs of my test, so it will come up first that, and then we'll see the next one. Okay, so here it is what we're going to create the slice now. So if you see in the previous step, I issued it and we got a slice ID back. And using the slice ID, you can in real time keep checking on the status of the slice creation. You can see slice alloc is happening
in progress is that. Now you can go to each of them and see what is the state. So ASP is the one who is responsible to do CSMF and NSMF role, right? So as per 3GPP spec, if you see there is a slice profile has to be created, service profile has to be there, right? And per each domain, you need to have the slice profiles, right? So all of that is happening in this background. ASP and core NSSMM and RAN NSSMF are actually doing that activity. And this is a very stable version which you can repetitively you can try. So any number of times it remains, very stable. And in any order you can bring any of these pods and it connects. So it has all the retries and everything in place today. So I'll fast forward this portion. So you can see in real time whenever the ASP will query and try to get the status of the slice creation. So when out of 3 domains, right, the transport, RAN, and the core, as one of them completes, the progress state will show 35% done, 70% done, or 100% completed. That you can see it. So here you can see like 35% is done because transport was a lightweight version, so it was able to do it fast. And then similarly, core and SSMF is bringing up the core and RAN both are trying to bring up the respective portion, right? So here you can see from the slice order, when you did it, it translated into slice profile and there is an ID assigned to it. PLM and info came in, RAN slice subnet profile got created and everything, all the other parameters as per the release 18 of the 3GPP, all those attributes we are showing here.
Is J1 configuration of network functions like a G0B attachment to an AMF is part of it?
Yeah. So now you can see that on the RAN side, G0B came up, and on the core side, so you can just, we'll just say on the core side, you can see the core network is coming up. UPF came up first because we defined 2 services, right? One for the control plane, one for the user plane. So UPF is an independent service, so it came up first, and the control plane is now coming up. In a few minutes, it will come up. So this is what the ordering problem I was saying. So URAN SIM is up and ready and it wants to connect to free 5GC, but free 5GC is not up yet, right? The control plane signaling is not up. So that way the URAN SIM was not able to succeed anytime. So we made the code changes in the URAN SIM to support that functionality. So now you can see the core and RAN, both of them is up and running. Right. So basically the slice orchestration has completed here. I mean, slice has come out completely. And you can see here from MPO GUI also that, there are 3 services which we created, one for control plane signaling for the control plane, and one URAN SIM, and one for the UPF. I'll pass this portion just to save time. Yeah, so I want to show the portion where we connect to free 5GC to see that a day-end configuration of adding a subscriber also, right? Because in order to make the UE to connect to the core network, subscriber configuration has to be present. So here is what we are showing that the core NSSMF also does that day-end configuration and then adds a subscriber automatically. So that is also been added in the core NSSMF. So here you can see a subscriber got added. Right? So this is the why you're seeing ahead of time without even we did a DN configuration changes is with the latest free 5GC. Now it has a PV support also. So when you do first time some couple of testing, you will see that the subscriber is now there all the time. So what we do is once the core network is up from core and SSMF, we send adding a subscriber. So manually I delete this to showcase for the demo, and then automatically core and SSMF will add this UE back. UE subscription profile it is going to add it.
Okay, that's your test subscriber.
Yeah. Yeah, so this is one of the flags which we have set it in the help charts, or you can tell to core and SSMF to say that you want to add the subscriber by default or you don't want to add it. So it's a Boolean flag. So if you don't want to set it and you want to do it manually, you can do it. So here is that you can see that you're sending an add subscriber request to core from core and SSMF to free 5GC, and the whole payload is sent. And free 5GC is now configured with a subscriber there. So if you refresh this page, you will see that a subscriber is added to the configurations of that. So DN configuration is ready there, and then it will have all the attributes which was defined by the operator in the beginning. So slice ID and everything what we had, right? Now what we're going to do is we're going to add manually only the UE portion to the RAN cluster, where only the G-Node B is running, right? So we're going to install only the UE to simulate that the UE will come and connect to the network and should be able to succeed. And so here is what UE is going to get installed. I'm going to do a Helm install of that explicitly to showcase that. And we'll see the logs in the VRAN sim and the G-Node B to see that it is able to successfully connect. So I'm installing that, if you see here, and if you can see the pod, the UE has come up. Okay, and we can check the logs there. In the logs, you will see that a tunnel interface, a GTP interface is up with an IP address, and UE got an IP address at 10.101. So it is ready to send the data traffic. And what I'm going to do next in this is immediately is that we're going to detach this UE from the network and reattach it automatically. That is what is going to emulate your mobility use case. Here, if you come and check, you will see that UE is connected, and you can verify the AMF and SMF logs here to showcase that it is connected, and it is connection state is up, and then you got an IP address for the video session is there. And yeah, you can see the slice ID, what we have given in the beginning is also reflecting the same. Okay? This is a validation of that whatever operator has set the slice ID is come all the way to the network functions. And this validates also that user is able to connect with the same slice ID. So now what we're going to do is I'm going to just run quickly the deregistration and the registration part to showcase the mobility. So there is an option in the UE to go and deregister it separately. So in one of the terminals, you'll see that I'm tailing the logs. And in the second terminal, I'll go into the UE pod, and actually I'll do a deregistration event manually to demonstrate that. So here is the step. So there are 4 options basically through which you can deregister in the network. Either you can switch off your phone, or disable the 5G, or you can remove the SIM, or you can just do a normal deregistration itself. So we're going to pick one of the methods to to exercise this. So you can see here the slice ID is the one which is matching, and what is IP address has been assigned to this UE. Right? Now we'll do a deregistration. So I'm going to do a deregistration command. So there are 5 options, like I was mentioning. Right? 4 options. Sorry, my bad. It's 4 options, and we're going to use the normal procedure to deregister it. So yeah, hold on. Yeah, so I'm going to issue deregister normal, and we'll see here a deregistration has kicked in, and the UE get deregistered from the network successfully. And in a couple of seconds, the UE will automatically start registering back with the network. So you will see that your RRC connections has been established back, and the UE got an IP back. Right, so it got a new IP this time, and if you refresh the page, you will see that 10.102 IP address is available to the UE. And so basically, UE is running up and running with a new IP address, and it actually is demonstrating the mobility use case, and it is on the same slice ID. So that's the overall demo. I have the last slide as the next step. So what we were thinking is to, based on 5G Super Blueprint use cases and the needs, right? We are thinking to take this solution and integrate towards, core network would be the next, could be SD core, because we have it in one of the labs there. Or we may promote to going to the next level and do OAI also. And similarly for the radio access network also, we wanted to do OAI and or along with taking the ORAN SMO to integrate in this demonstration, so that we have a slicing with the ORAN SMO as end-to-end case. And what 2 more use cases which I'm likely to go forward is, which is meaningful in our 5G Super Blueprint, is to integrate the edge placement and site selection scenario, which Rodney was showcasing in the morning, right, which is relevant for the slicing very much. Right? So that's one portion we are looking at it, and also to see how the Nephew can fit in into this solution, or how we can help Nephew to demonstrate the capability for the slicing. So those are our next steps are.
It's
With this,
awesome.
yeah, so with this, I will leave it to if any questions if I can take. I know I'm overshooted the session a bit.
I think it's an awesome work, Yogendra, and I like the way you guys scripted the demonstration. You covered most of it, therefore I don't have any more questions.
Thank you so much.
Any more questions before we close this session? Yogan, thank you so much.
I'm sorry, I'm just gonna ask, are we well past time and I should keep my mouth closed, or how are we doing on time? Oh, we're well past time, so never mind, I'm keeping my mouth closed.
We are six, it's okay, Heather.
All right, cool. And especially because it was going to be sort of a kind of larger strategic question, which is even more why I should not ask it when we're over time. But thank you, Yogendra. This was a really interesting presentation and demo.
Yeah, thank you, Heather.
Heather, feel free to follow up with your question and we'll certainly get it in front of the community.
Yeah,